Hey everybody, this is Larry. This is day 20 of the Advent of Code. In the year 2024, hit the like button, subscribe, and join my Discord. Let me know what you think about today's Advent of Code. Okay, so we have about 90 seconds to go. I am in El Salvador. I am in Santa Ana. And I am very tired. I basically did not sleep yesterday. I slept like an hour on the plane, and I am excited to just finish this and going to bed. If you want to watch me solve yesterday's problems, check out that video. I did it on the plane, even though I started late because I was just at the airport and all kind of chaos ran out. But today I am hopefully a little bit better. Hopefully, honestly though, hopefully the problem will be way quick and easy because I really want to go to bed as the TLDR. So we'll see how it goes. We have 45 seconds to go. And yeah. Yeah, let's go, 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 go. I am so tired, honestly. But yeah, hit the like button, hit the subscribe button, join me on Discord, I suppose. Yeah, 10 seconds to go. Let's go. 5, 4, 3, 2, 1. Go, go, go. Oh, it's another good one, really? Well, at least, hopefully, this is a easy good one. Okay, I mean, it's interesting, but I feel like still maybe the same. I don't know. I don't know if my intuition is right though. At least for part one, maybe it should be, I don't know. It just reduce all wars, right? Okay. All right. I want to see the size. 140 of, that's not even that big, right? This is where I wish I had a thing ready, right? I mean, I feel like we did this already, so maybe this is like almost like encode where you're doing it again, kind of thing. Like I maybe it would have been faster if I just found the code and copy pasted. Honestly. Because I'm like literally implementing the same thing again, which maybe is just dumb on my part. Yeah, at least this is what I was asking for, which is that it should be fast. Right. Yeah. My laziness this time has gotten me. I don't return anything. But also, come on, Larry. Even the test doesn't pass. That's wild. Why? I'm done. Oh. Why does it go out of bounds? I thought it shouldn't go out of bounds. The way that I set it up, but maybe not. 0 probably sounds right. This is kind of slow. I mean, it'll finish running, but it's kind of slow. 114. Let's open up another window, just in case that this is wrong as well. How can I make it faster? I mean, I guess I could write BFS a little bit differently by adding a state. Maybe. I don't know. No, that's true, actually. I mean, I was going to write a thing to eliminate the border, but that only changes, like, not that much. Hopefully this is right, but I don't think I'm on the leaderboard anyway. And part 2 may be super annoying. We will see. In theory, it should only do the thing that I thought it was it's 141, right? Not 114, whoops. In theory, it should be only the thing that touches the optimal path, right? So we can maybe run on optimization on that, right? But I'm so tired and lazy and we're almost done, I suppose. Unless we're wrong. 0, okay, well, then we're wrong and we're no Gucci. All right. Why does that put 2? baseline is 84. Is that right? Okay, and then everything is 84. Why is everything 84? Oh, well, couple is fine. Huh? If this prints, then why is it not? Oh wait, it doesn't print. That's the problem. Oh, whoops, I did the direction wrong. Larry, 44, that is also wrong. Oh, save 2 exact seconds, so that's not quite the same. I mean, I'm too slow anyway. Okay, I think I'm right now, but this is going to take a long time to run. There should be only things that change the baseline, right? So, okay. Yeah, this is going to be a while, so maybe I can write I'm dumb. That was pretty bad, actually. Okay. And also, if I was using not Python, this would be much faster, but that's besides the point. We're halfway done anyway. But I can't even. Today is not my day, and part 2 is going to be nightmare. Hopefully not. I'm just not grinding it out, honestly. Okay, if this is wrong, then I'll grind it out. I'm just so maybe today is such a rough day. Can't believe I got the wrong sign though. Some days I am just no Gucci. Okay, 185. Actually, I could have gotten high score maybe, but that is tough now. I'm actually surprised because I guess people just didn't YOLO it like I did. 20 seconds is a tough one. I mean, we could find one path. What is the answer for the baseline? 9,300. Who knows? Maybe I could have gotten top 1 of the 100 if I was not dumb about it. But it's basically the same thing but less dumb. Okay, but my other strategy wouldn't work. It's just DP then, right? that it? This may actually run out of time. Time is really big. Used is, yeah, used is okay, but we'll see. Time is always going. That's not quite right for part one, so I think, I mean, the recursion thing is another thing, but I don't want to fix it if it doesn't do anything. Also, this can also be breadth first search with DP, but I don't know what's wrong with the thing with part one. Why is it returning so ridiculously? 84. Do I have to take a unique path or something? Because I guess I'm counting paths that go back and forth. Huh. That's probably why. Maybe. I don't know if that's true. Well, like, yeah, we use do. This is not right. Because I guess it allows me to go back and forth. Because I think using a cheat and then has to do the shortest path. So then back and forth doesn't make sense. Okay, I think I get why my code is wrong then. How many people have gotten this yet? This is not a go to sleep early thing. Top 100 people got it already, so at least I don't have no pressure. Maybe they did it right the first time, unlike me. But I'm surprised I still did that well relatively. I think the idea is just that so cheat is just a Euclidean distance. I don't know how to make it so that is a unique path. I think that's my tricky part for this one today. Because my other thing just counts multiple paths at the same time, which does, as long as it fits under, which doesn't make sense. Because it's that, yeah, it's not equivalent because you have to calculate it on a cheat graph or something, right? Oh, wait. Oh. It's the same cheat. Wait, I have to maybe figure out what that means. Wait, can you only cheat once? Oh, I misread this. Oh no. Yeah, okay. Yeah, I misread this. I mean, I actually set it up so because I was on the same path, like with the reverse BFS, but yeah, yeah, okay. I don't want to write this. Yeah, I misunderstood this one, but yeah, okay. Right. The other way around, Larry. You already messed it up once. I don't think this is right, but I figured, you know, it would take me longer than that to debug. Why did I print so much? Oh, I baseline is what? Why do I print that much? What am I printing? Maybe I print the wrong thing somewhere. Oh, this thing changed. Okay, so it's not 212. Why not? I get 13 for 76, so that's not right. Why do I think it's 13? Three, 1, 2, 1 doesn't sound right. Actually, that sounds right, but in the trivial sense. Oh, if it doesn't do anything, why would that be? Oh, because D is 1, but then what is the baseline? What is this? Oh, this is R graph. Oops. Okay, well, that would explain some stuff. Okay, 1. Okay, so I'm just bad at everything today. I set it up and then I just get it wrong anyway. 246. Is that better? Nope. Okay, what is the 76, right? For the testing. Oh, I only show 1, so that's not right. There should be 3 is what I think, but maybe I just kind of wasn't paying attention enough. 3175, 31. I see, the 3 is going to be, but they all start at the same, that's why. If anything, I should overcount, right? Why is this not counting like from 3, 3? Oh no, 3, 3 is a. So it would give an infinity. Three, 1, 2, 7, 5. Well, that's just a straight path. So there's 3, 7. Why not 2, 7? Okay, so then now I want to say. Oh, because no, that makes sense, but too slow on today. Okay, 2, 1, okay, 3, 1, okay, that doesn't make sense. That doesn't make sense. Does reverse graph everything? Is my reverse graph wrong? My reverse graph is definitely wrong. That only has like 3 things. Oh, oops. Okay. It's long. At least maybe it's doing something. It was running quite fast before. That seems very high. Oh, that's right. I mean, I don't know. I knew the algorithm right off the bat, kind of. Like, I knew the idea, but I just misread some parts of it. Yeah, that was kind of silly. How long did that take anyway? I mean, I don't know. I just made a lot of mental mistakes, frankly. I'm surprised this was so fast, or like this was high rank, but maybe a lot of people just saw part 2 with part 1 and I just YOLO'd it. 6 seconds was actually pretty not bad. But and I knew, well, yeah, I mean, I wasn't that fast, but I misread this a little bit, which shows up in my dynamic programming understanding, because I thought you could keep on going. Well, I thought that I was just looking for paths I was going to go back and up. I think actually the keep on going thing doesn't even make sense, but I think, or rather, I thought that you could use it more than once. It's just 20 seconds combined. So like you could use it in the beginning and then do regular things and do it again. And it kind of shows up here. And then when I reread it correctly, I already had this idea of this reverse graph in the middle thing, but basically, yeah, I just didn't know how to do it. Or I knew, I just didn't know how to read it correctly, and then I just didn't know how to implement it. I just got lazy on the copy and paste. I missed this part, and that kind of took me maybe 5 minutes to debug, which is, I don't know, fine, I suppose. So tired, I'm gonna go to bed soon. But let's do a quick explanation. Part 1, I don't know it's worth explaining. I just did the breadth first search. The key note is that if you can only remove 2 seconds at a time or whatever, that means that you can only remove 1 war, right? You could optimize for it by doing part 2 basically, but that's basically what I did. Mine took a long time, frankly, so I don't know how long that took. Let me run, but you know. Yeah, basically I run it once for regular breadth first search. The second time if I see a war, I remove it and then put it back in. And with this baseline, you print. Of course, you can even do slight optimizations like linear time optimizations, but that's going to be the idea, right? Yeah, like. And then part 2 is this idea of kind of merge in the middle. And connecting things, but like I said, I misread a good part of it. But the idea here is that okay, because the only thing that defines a unique cheat mode, and I'm bringing up the drawing right now, the only thing that identify a unique cheat mode is that the beginning and the end of the cheat mode, right? So if you have something like, you have a grid. I'm drawing with my touchpad, so please forgive me. Actually, I'm not even going to draw it out, but it just like, if you have, it just depends on what these 2 things are, right? And as a result, this thing is just the Eulerian, or not Eulerian, what's it called, Manhattan distance, right? Because basically when you activate cheat mode, well, one is that you always want to activate all 20 seconds. Why not, right? So as a result, and because it doesn't change anything, because if you define the beginning at the end, as long as they're within 20 seconds, you're fine. And as a result, you can kind of brute force all of this. Actually, I kind of, we can do an optimization, or we could try an optimization that's based on this instead. But yeah, but that's the idea, right? Is so that now you're doing 20 or 400 is search, which maybe is faster. But yeah, right? And then now you have all these, then that means that you have some starting point. You know how long it takes to get to this point, and then you have some endpoint, which you also know what the the BFS distance is. So then now you just brute force them all together, and that's pretty much it. That's the idea behind it, and that's what the code does. I BFS from the beginning point. I BFS from the ending point. Of course, I implement this incorrectly because I copy and paste, and I just missed this part, and I was getting confused things. And then yeah, I have a graph and reverse graph, or a graph that starts from the end graph, and then I just calculate the baseline just because, well, we already have the baseline calculated, so we just get it out. And then yeah, we get the Manhattan distance, and if the Manhattan distance is less than or equal to 20, we check, right? This is the graph from the beginning to this point. This is the graph. This is the reverse graph from the end to the point, and then D is the Manhattan distance. So you're trying to connect all three things as we kind of graphed it out. I know maybe I'm a little bit fast. My apologies. I'm so tired. My excuse. Tomorrow, hopefully, I'll sleep better, and yeah, or tonight, I suppose. But yeah, if the baseline is greater than 100, then you add a count. There's some ways you can optimize for this. Noting that, let's see. Actually, let me take a look real quick. Yeah. Oh yeah. So part one took almost 2 minutes, by the way. So actually, it's kind of funny because I actually already ran part one. So I wonder why, I mean, it would have taken like 9 minutes because or like even less. So I would have gotten 100, I don't know, maybe not top 100, but would have been really close because 8 minutes and 32 seconds. So because I had an if statement that was wrong and then I had to run it twice, each at taking 2 minutes. So I almost was top 100 on part one, but part two, I just misread terribly. It happens. I don't think I could have gotten in 5 minutes though. Maybe I could have. I don't know. I think this wasn't that bad. I immediately had some sort of that idea, but I didn't know. But anyway, so what we're doing, because graph and reverse graph is 9,400 nodes, we can actually reduce this, right? We can say, yeah. So then now instead of iterating here, we can say, just iterate all the points that are within distance of each other, right? What that means for x in range of R, for y in range of C, right? So then now maybe, how do you write it? So if, first of all, it has to be a thing, right, to start. And then now you just write for dx in, was it 20, right? Yeah, I mean, maybe you could do some Euclidean math such that it is, yeah, like, yeah, I don't know, but you can definitely optimize for this. But I'm just running a little bit lazy, and even this is faster, right? Because this is every cell that is doable, and then this is only 400 versus 9,000, right? So this should be at least 20 times faster already. Maybe not quite because maybe this part is a little bit higher, but as a result, right now, yeah, and then we just write the same thing, which is, actually maybe, yeah, we'll just keep the same notations, right? So yeah, and then x2, y2 is equal to x1 plus dx, y1 plus dy. This is a little bit off because I think you have to go from -20 to 20, or 21 even. But still, then now this, you can just count this. So maybe it's not 20 times faster, but it still should be faster. And just because I'm lazy, I think you can actually do very well. It's just that I am lazy. Yeah. Okay, well, we're just returning 0, so that's not great. I mean, I guess you can check. Yeah. I don't know. I don't think that matters. But why does this work? Well, this doesn't even ever go here. Oh, because I used X. I renamed some variables I didn't rename there. Okay, maybe I'm wrong. Maybe. Oh, no, I mean, this is twice as fast as a result. So yeah, as you can see, and I didn't even like, this is really lazy way of kind of going through the Manhattan distance boundary, right? I'm just kind of actually, this should be twice as slow, because if you think about it as a square, and then the Manhattan distance is a diamond, then we're checking the square, we only care about the diamond, so that's only half of it. So if you do it smartly, you can do this to 1 second, which is like 6 times faster, right? Which is already Gucci. Yeah, I don't know. Anyway, that is all I have for today. Let me know what you think. Thanks for watching. And yeah, I'm really tired. I'll see you tomorrow. Hopefully I'll be less tired. And bye-bye.